Hi, welcome back. We're going to talk about inverse functions and relations. So we're going to define and create an inverse relation. So this is going to be talking about ordered pairs, relations. We're going to define and create inverse functions. So we're going to be using equations and finding inverse equations. And then how do I determine if two functions are inverses? We're going to use the composite function again. Right? Inverse relations. Two relations are inverses if and only if whenever one relation contains the pair AB, then the other relation contains the pair BA. If you prefer X's and Y's, it says if one pair has the ordered pair XY, then the inverse relation has the pair YX. So in other words, the domain and the range are flipped. The X and the Y's are flipped. The inputs and the outputs are flipped. Those are all different ways of saying the same thing. So given the relation A, find the inverse. Well, we're going to write it like this, A inverse. And it looks like an exponent, but it's not. It just means when you have a capital letter like that with an inverse, a -1, it means the inverse relation. We're going to flip our ordered pairs. It's as simple as this, 5, 1, 6, 2, 7, 3, -3, -7. That's the inverse relation. The ordered pairs are flipped. The X's and Y's are exchanged. The domain, whenever we have ordered pairs, it's just every single X value. It's different when we have an equation, but for ordered pairs, it's going to be 5, 6, 7, -3. The range are going to be all the Y values. 1, 2, 3, -7. So why don't you try this one on your video question and come back and see if you got it. All right, I'm going to look for inverse of B. And so I'm going to flip my domain, or my X's and Y's, my domain, my range, my input, my output. So it's going to be 4, -2, -4, 3, 0, 6. I'm going to state the domain. It's going to be my X's, 4, -4, 0. My range is going to be -2, 3, and 6. Now we're going to talk about inverse functions. So we're going to have an equation and we're going to find the inverse of it, okay? And so it's not a different rule, it just kind of looks different because we're working with letters instead of ordered pairs. The rule says that if two functions are inverse of each other, if and only if, when f of a equals b or f of x equals y, if you prefer that, then f inverse of b equals a. It's just saying that the ordered pairs are flipped. This symbol, f -1 like this is red, f inverse of b, f inverse of b, or it could be f inverse of x, f inverse of x. So don't think of it as 1 over f. It's the inverse. It's the switching of the domain and the range, switching of the ordered pairs, switching of the x and y's. So to do this, we're going to start with an equation, and the equations are going to be in function notation. So this first step is just to make our life a little bit easier, and the fourth step is to make our life a little bit easier. So what you're going to do is you're going to write f of x back as y. So y equals 2x minus 5. And then you're going to switch the x and the y. So x equals 2y minus 5. I just switched them, just like I did with the ordered pairs. And now I'm going to solve for y. So I have x plus 5 is equal to 2y, and now I'm going to divide by 2. X plus 5 over 2 is equal to y. And now this y was a result of switching my x and y's. So this represents f inverse, okay? So I'm going to write it as f inverse of x equals x plus 5 over 2. And we can also graph these on the same number line, and you're going to see that they're flipped over the line y equals x. All of the ordered pairs are switched between these two graphs. So go ahead and try this one and on your own as the video question, and then come back and I'll do it with you. All right, here we go. So I'm going to write it as y equals negative 1/2 x plus 1. Then I'm going to switch the x and the y. X equals negative 1/2 y plus 1. Now I'm going to solve for y. X minus y equals negative 1/2 y. Now I'm going to multiply both sides by negative 2. Okay? I'm going to do that to cancel out this negative 1/2, right? So I'm going to get negative 2x plus 2 equals y. Now remember, this is my f inverse. So f inverse of x is negative 2x plus 2. So now let's graph this, okay? I'm going to use for my original function that my y-intercept is 0, 1, and that my slope is negative 1/2. So that means my line's going to be going downhill from left to right. So here's my point, and then I'm going to use my slope. Up 1 over 2 to the left. 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 Down 1 over 2 to the right. 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 And then I'm going to connect this line. All right? Let me see if I can get that a little bit nicer. Okay. Now let's do f inverse of x. That y-intercept is 0, 2. And that slope is negative 2. So again, my line is going to be going downhill from left to right. Here's the point 0, 2, and then I'm going to go up 2 over 1, up 2 over 1. Oops, started in the wrong spot. Up 2 over 1, up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, and we just keep going. Okay, and then I'm going to try and connect this dot. So I want to point out an example here. Notice that this point right here is 0, 2. Okay, 0, 2. If these lines are inverses of each other, then on the purple line should be the point 2, 0. Isn't correct? And look right here, this is the point 2, 0. And all of those points will do that. Okay. Now we're going to do one that's with a squared, but it's the same process. You just have to think through how do you undo a square. So we're going to write it as y equals x plus 3 squared. Then we're going to switch our x's and y's. Then I'm going to solve for y. So I have to take the square root of both sides, plus or minus. Plus or minus the square root of x equals y plus 3. Okay. And then I'm going to subtract 3. Negative 3 plus or minus root x is equal to y. This becomes my f inverse, so I get negative 3 plus or minus root x. Now I'm going to graph both equations. Now to do this one, and I could have done it on the other one, I'm going to graph my parabola first. This is my parabola, and then I'm going to use the idea that my x's and y's are flipped. So here we go. So here's x, here's f of x. I'm going to start with my vertex. That's -3, 0. And then if I plug in a -2, I'm going to get 1. If I plug in a -1, I'm going to get 4. Then I'm going to use symmetry. -4 is 1 and -5 is 4. So let's graph those. Here, oh, x. And then here, and then here, and here, and then we graph it. Now everything is flipped over this line, so that means I get to exchange my x's and y's. So I'm going to change my color here real quick, and I'm going to graph at the f inverse of x. And to do that, all I'm going to do is take this set of ordered pairs and I'm going to flip them. So I'm going to get 4, -1. We're doing the same thing we did with ordered pairs, but now it's in table form, so don't get confused. 1, -2, 0, -3, 1, -4, and 4, 4, -5. And I'm going to graph it over here. So I have 0, -3 here. And then I have 1, -2 here, and 4, -1. And then I have 1, -4, and then I have 4, -5. And so I get my parabola that looks like this. Okay? And these are inverses of each other. All right, now we're going to determine if two functions are inverses, and we're going to do that by looking at the composite function. All right, and we're going to look both ways at the composite function. Okay, we're going to do f of g of x and g of f of x, and they both have to simplify down to x in order for them to be inverses. All right, so here are my two functions. F of x equals 3/4 x minus 6, g of x equals 4/3 x plus 8, and now I'm going to find f of g of x. So that means I'm going to plug g into f. All right, so here we go. I'm going to plug g into f. So f starts with a 3/4, and then I hit an x. So that means I'm going to plug in 4/3 x plus 8, and then I'm going to subtract off 6. Now I'm going to distribute the 3/4. These are reciprocal, so they cancel, so I get x plus 3/4 of 8 is 6, 6 minus 6, and so I get a 0. I'm sorry, these cancel, and I get an x. Then I'm going to do g of f of x. So I'm going to plug f into g. So I'm going to start with 4/3, and I'm going to plug in f. 3/4 x minus 6 plus 8. When I distribute this, I get x minus 8 plus 8. The 8's cancel, and that simplifies to x. These are the same, so these are inverses of each other. So this is yes, because f of g equals g of f equals x. All right, I want you to try this one on your own as part of your video question. And then I'll do it with you. All right, so I'm going to find f of g. This is f of g, right? So I'm going to plug g into f. So I have 3 from f, and then, I hit an x. So I'm going to plug in 1/3 x plus 4 minus 3. Now I'm going to simplify. I get x plus 12 minus 3, and that gives me x plus 9. It didn't equal x, so you know these aren't going to be functions. Let's try g of f. This is g of f, right? So I'm going to start with g, 1/3, and then I hit an x. So then I'm going to plug in 3x minus 3. Then I'm going to add 4. And I'm going to distribute, so I get x minus 1 plus 4 is equal to x plus 3. These are not inverses because f of g does not equal g of f, and neither one of them equal x. All right? All right, I'm going to do this one with you. Okay, so let's try this. We have to let's find f of g first. So that means I'm going to plug g into f. Okay, so here's my f. I have 2, and then I have an x squared. So here we go. I'm going to do x plus 1 over 2, and I have to square that, minus 1. So whenever you square a square root, you're going to end up with 2 times x plus 1 over 2 minus 1. And then I'm going to cancel these 2's, so I get x plus 1 minus 1, so I get an x. So we're going to try the next one. So now I'm going to find g of f of x, and I'm going to plug f into g. All right, so I'm going to have to scoot on down here. Here's an x, so I'm going to put in 2x squared minus 1 plus 1 over 2. This is my f of x. Okay, and then I'm going to simplify my numerator. And that's going to give me 2x squared. These cancel over 2, and there it's under a square root. My 2's cancel, so I have the square root of x squared. Okay, so that equals plus or minus x, or you could say the absolute value of x, but it equals plus or minus x. So we have to be careful, because as long as these are inverses, as long as x is positive. If x is negative, then it doesn't work. Okay? All right. So one more thing to look at. Remember that the vertical line test for a graph will tell you if it's a function. All right, so if you drop a horizontal line through a function, it'll tell you if your inverse is also a function. So a horizontal line test that crosses only once means the inverse is a function. If it crosses more than once, the inverse is not a function. In general, odd degree functions are more likely to pass the horizontal line test. So their inverses are functions too. Sometimes when you get a lot of middle terms in there, like if you're in really high, like x to the 7th, it might not work like that. But a lot of x cubes are. Even degree functions never pass the horizontal line test, so their inverses are never functions. This is because the arrows point in the same direction. But you can restrict a function's domain, like with the square root function, so that its inverse is a function too. So this will be your video questions, or your daily assignment for tomorrow. So I'll see you then. Thanks for listening.